Welcome to our deep dive into Ganymede, the king of moons. Not only is it Jupiter's largest moon, but it's also the largest moon in the entire solar system, bigger than Mercury. Thanks to NASA's Galileo, Juno, and the Hubble Space Telescope, we've made some stunning discoveries about this epic moon. So buckle up, space fans, as we explore the wonders of Ganymede. When you think of celestial bodies with magnetic fields, you probably picture giant planets like Earth or Jupiter, right? These massive worlds with their swirling cores and dynamic atmospheres are the usual suspects when it comes to generating magnetic fields. But Ganymede throws a wrench in that assumption. This moon, orbiting the gas giant Jupiter, defies expectations. This moon is the only one in our solar system known to generate its own magnetic field. It's a fascinating anomaly in the cosmic neighborhood. We're talking about a mini magnetosphere, a protective bubble of magnetic energy surrounding this icy moon. This groundbreaking discovery was made by NASA's Galileo spacecraft in the 1990s. The mission provided a treasure trove of data that changed our understanding of the solar system. Imagine the data streaming back to Earth, revealing that this moon, this seemingly simple ball of rock and ice, possessed a magnetic personality all its own. It was a revelation that sparked excitement and curiosity among scientists. Ganymede's magnetic field interacts with charged particles from Jupiter's colossal magnetosphere, creating auroras. These interactions are a cosmic dance of charged particles and magnetic forces. Yes, auroras, those shimmering curtains of light we associate with the polar regions of Earth, also grace the skies of Ganymede. They are a stunning visual testament to the moon's magnetic prowess. Ganymede's auroras are supercharged by Jupiter's powerful magnetic influence. The interplay between these two celestial bodies creates a light show like no other. Imagine the most vibrant, dynamic light show you've ever seen, amplified to an interplanetary scale. It's a spectacle that would leave even the most seasoned astronomers in awe. This discovery was a game-changer, forcing us to reevaluate our understanding of moons. It challenged the notion that moons are just passive satellites. We used to think of them as passive objects, merely orbiting their parent planets. But Ganymede shattered that perception. But Ganymede, with its magnetic swagger, showed us that moons can be dynamic, complex worlds with their own unique stories to tell. They are not just secondary characters in the cosmic play. So what causes Ganymede's magnetic field? What is the source of this magnetic marvel? The leading theory is that deep within its icy heart, Ganymede harbors a molten, metallic core. This core is the engine driving the magnetic field. This churning, electrically conductive core, much like Earth's, is thought to generate the moon's magnetic field. It's a process that mirrors the dynamo effect seen on our own planet. Think about that, a molten metal heart beating within this icy giant. It's a juxtaposition of fire and ice, a paradox that makes Ganymede all the more intriguing. It's like something out of a science fiction novel, but it's real. The wonders of the universe never cease to amaze, and it's just one of the many incredible secrets that Ganymede holds. This moon is a treasure trove of mysteries waiting to be uncovered. This discovery of a magnetic field wasn't just a cool scientific footnote, it was a pivotal moment in space exploration. It opened up a whole new avenue of investigation, hinting at a dynamic interior and a celestial body far more complex than we ever imagined. Ganymede continues to inspire and challenge our understanding of the cosmos. Ganymede is a bit of an overachiever, magnetically speaking. This moon, the largest in our solar system, is not just a giant rock floating in space, it has a magnetic field which is quite rare for moons. But hold on to your space helmets because this moon has another trick up its icy sleeve, a hidden ocean. Yes, beneath its frozen exterior lies a secret that could change our understanding of where life might exist in the universe. You heard that right, folks, an ocean, and not just any ocean, but a colossal, potentially life-harboring ocean. Imagine an entire world of water, teeming with possibilities, hidden beneath a thick layer of ice. Scientists estimate that this subsurface ocean lies beneath Ganymede's icy crust, stretching some 100 kilometers deep. That's a staggering depth, making it one of the most intriguing places in our solar system. That's over 10 times deeper than the deepest part of Earth's oceans. The Mariana Trench, the deepest part of our oceans, pales in comparison to the depths of Ganymede's hidden waters. We're talking about an ocean so vast, it could hold more water than all of the oceans on Earth combined. Just imagine the sheer volume of water and the mysteries it could hold. So how do we know this ocean exists if it's hidden beneath all that ice? The answer lies in the clever use of technology and scientific ingenuity. The evidence comes from several sources. Spacecraft like Galileo have been instrumental in uncovering these secrets. The Galileo spacecraft detected subtle variations in Ganymede's magnetic field, which scientists believe are caused by the flow of electrically conductive salt water deep beneath the surface. This is a strong indicator of a vast hidden ocean. We can't see the ocean directly, but we can observe its effects on Ganymede's magnetic field. These magnetic anomalies provide a window into the moon's hidden depths. The Hubble Space Telescope has also chipped in, observing auroras in Ganymede's atmosphere. These light shows are more than just beautiful. They tell us about the moon's hidden ocean. These auroras behave a bit differently than expected, and the presence of a salty subsurface ocean perfectly explains these auroral quirks. The interaction between the ocean and the magnetic field creates these unique auroral patterns. This hidden ocean, with its potential for hydrothermal vents and the right chemical ingredients, could be a haven for extraterrestrial life. The conditions might be just right for life to thrive. Think about it. Alien creatures swimming in an ocean beneath an icy moon, completely cut off from the surface. It's a tantalizing possibility that excites scientists and dreamers alike. The existence of this ocean catapults Ganymede into a whole new category of celestial bodies. It's not just a moon, it's a potential cradle of life, a cosmic oasis in the vastness of space. It's not just a moon, it's a potential cradle of life, a cosmic oasis in the vastness of space. This discovery opens up new avenues for exploration and understanding, and it begs the question, what else might be lurking beneath the surfaces of other icy moons in our solar system? The search for life beyond Earth has never been more exciting. Ganymede's surface, a story written in ice and grooves. We've journeyed into Ganymede's magnetic heart and plunged into its hidden ocean, uncovering secrets that lie beneath its icy exterior. Now let's shift our gaze to the surface of this enigmatic moon, where the story continues to unfold. Ganymede's surface is anything but boring. It's a landscape that tells a tale of cosmic drama and geological activity. It's a captivating tapestry of light and dark terrains, crisscrossed by grooves, ridges, and furrows that hint at a dynamic and complex past, shaped by forces beyond our imagination. Imagine looking out from a spacecraft window as you approach Ganymede, seeing this alien world up close. You'd see vast, brighter regions, ancient and heavily cratered, like the lunar highlands we're familiar with, but with their own unique characteristics. But then, your eyes would be drawn to darker, younger terrains, marked by an intricate network of grooves and ridges, each telling a different part of Ganymede's story. These grooves and ridges are not random scribbles on Ganymede's face, they are the signatures of powerful geological processes. They're the result of tectonic-like processes, forces that have reshaped the moon's icy crust over billions of years, creating a landscape of constant change. It's like Ganymede has its own version of plate tectonics, but instead of molten rock, we're talking about massive blocks of ice, shifting and grinding against each other in a slow, frozen dance. Scientists are still trying to unravel the full story behind Ganymede's tectonic shenanigans, piecing together clues from every available source. The leading theory is that these processes are driven, at least in part, by the moon's hidden ocean, a vast reservoir of liquid water beneath the icy crust. Imagine the immense pressure exerted by that colossal body of water, pushing and pulling on the icy shell above, creating stress and movement. It's a cosmic tug-of-war, and the surface of Ganymede bears the scars of this epic battle, a testament to the moon's dynamic and ever-changing nature. Ice volcanoes, eruptions of a different kind. We've talked about Ganymede's magnetic field, its hidden ocean, and its tectonically active surface. But there's another intriguing piece of the puzzle. The possibility of ice volcanoes or cryovolcanoes. Yes, volcanoes that erupt with ice. Instead of fiery molten lava, picture geysers of water, ammonia, or slushy ice mixtures erupting from Ganymede's interior, painting the surface with exotic ices. Scientists have identified several regions on Ganymede that show features suggestive of cryovolcanic activity. We're talking about smooth, dome-shaped structures, often surrounded by what appear to be flow features. Think of them as frozen rivers of ice. These features are strong indicators that Ganymede might be a lot more volcanically active than we once thought. On icy moons like Ganymede, water ice can behave like rock does on Earth. At those frigid temperatures, water ice becomes as hard as rock and can flow and erupt in a similar fashion to molten rock on Earth, just at much, much lower temperatures. Hubble sniffs out water vapor. Ganymede's atmosphere revealed. We've explored Ganymede's magnetic personality, dove into its hidden ocean, trekked across its tectonically active surface, and even witnessed the possibility of ice volcanoes. But there's one more layer to this cosmic onion: Ganymede's atmosphere. While Ganymede's atmosphere is incredibly thin, almost non-existent compared to Earth's, it's there, and it holds valuable clues about the moon's composition and activity. In 2021, the Hubble Space Telescope made an incredible detection. It found evidence of water vapor in Ganymede's atmosphere. Scientists had suspected for a while that water ice on Ganymede's surface could sublimate, going directly from a solid to a gas, and contribute to the moon's atmosphere. But this was the first time we had direct observational evidence. The discovery was made by reanalyzing archival data from Hubble observations taken back in 1998. Scientists were specifically looking at ultraviolet images of Ganymede, and when they compared these images to ones taken more recently, they noticed subtle differences in the auroral bands. These differences pointed to the presence of water vapor in Ganymede's atmosphere. The detection of water vapor provides further evidence to support the idea that Ganymede has a subsurface ocean. Ganymede is more than just a giant moon, it's a world of its own. From its magnetic field and auroras to its hidden ocean and potential for cryovolcanism, Ganymede has captivated our imaginations and pushed the boundaries of what we thought was possible in our solar system. With a massive hidden ocean, a magnetic field and auroras, geological activity and potential ingredients for life, it might just be one of the most fascinating and important places in the solar system for future exploration. Imagine the discoveries that await us as we send probes to orbit Ganymede, study its surface in detail, and perhaps even one day, drill through its icy shell to explore its hidden depths. Stay tuned for more cosmic discoveries and explorations. The universe is full of wonders, and Ganymede is just one shining example of the incredible diversity and beauty that awaits us as we continue to explore our cosmic neighborhood.